This is Algebra 2, Lesson 3-2, Solving Systems Algebraically. Equivalent systems are systems that have the same solution. Now, we've solved systems and equations in Algebra 1, and we've done a little bit in geometry. We used graphing, and we also used substitution and elimination. We will continue to use these three methods, as well as adding a fourth method toward the end of this chapter and the beginning of the next chapter. Now, when you try to solve a system of equations by graphing, the coordinates of the point of intersection may not be obvious. For example, if they don't land on an exact intersection between a point, like -2, 3. If they land between a coordinate point, then it's kind of hard to guess exactly where that is. Therefore, algebra is probably the easiest method to allow for solutions. We're going to look at solving systems of equations algebraically today. We're going to look at both substitution and elimination, and/or what they call the addition method. Let's take a look at this first set of systems here. We have this system -2x plus 5y equals -2, and x minus 3y equals 3. When you solve by substitution, it doesn't matter which equation you choose to get written in a single variable. It is easier, however, if you already have an equation in which one of your variables does not have a constant term in front of it other than 1. For example, if I was to number these equations, if I was to number this equation 1 and this equation 2, if I look at equation 2, x is all by itself. It doesn't say 3x or -5x or -7x. So it would be really easy for me to solve this equation for x, which is what I'm going to do. I'm going to do that by adding 3y to both sides. So now I have x equals 3y plus 3. Now that I have equation number 2 solved for x, I can simply substitute in 3y plus 3 for x every time I see it in equation number 1. So in equation number 1, I have -2 times x, which I've already determined is 3y plus 3. So I'll plug in the 3y plus 3 there, plus 5y equals -2. Now all of this is in terms of y, and I can solve for y just like a normal equation. So I would get -6y minus 6 plus 5y equals -2. If I simplify -5y and -6y and positive 5y is -y minus 6 equals -2. If I add 6 to both sides, I will have -y equals +4, which means that y equals -4. Once I've solved for what y is, I can plug that back into this equation right here, so I can solve for x. So x is going to equal 3 times -4 plus 3, which in this case is -12 plus 3, which happens to be -9. Once you've solved an equation, what you need to do is put it in coordinate point form. This is 2 equations, 2 unknowns, so it's going to be x, y form. So I will put x first, and I will put y second. And of course, we can always check our solutions to make sure that they are true. And I'm going to show you how to do this really quickly down here at the bottom. So if you get to a quiz or a test, and you're not quite sure, you can quickly check and determine. So to check it, if we take that first equation, which was -2x plus 5y equals -2, and I'll put in -9 for x and -4 for y. So I have -2 times -9 plus 5 times -4, and that's supposed to equal -2. So let's check that out. This is +18 minus 20. That doesn't equal -2, so that checks. Now we have to make sure that it checks for the second equation as well. So let's plug in the second equation, which was x minus 3y equals 3. Again, plug in -9 and -4, so x is -4 minus 3 times -9. That's supposed to equal 3. So I have -4 plus, oops, let's plug it in the right way. Back here, I already knew that wasn't going to work. So if I plug it in, x is -9. -9 minus 3 times -4. That's better. Does that equal 3? So I'm going to have -9 plus 12. Does that equal 3? Yes, it does. So both of those check. Therefore, -9, 4 is a solution to my equation. I'm I'm not going to check all of them, but I wanted to show you how to check them so that you can check them on a quiz or a test, which I highly recommend. Here we have the second equation here, second problem. Here's equation 1 and equation 2. It doesn't matter which variable I solve for, but it's a whole lot easier to not involve fractions. So I'm going to take equation number 1 and I'm going to solve it for y. And I'm going to do that by just adding y to both sides. So now I have 3x equals y, or y equals 3x, whichever way you want to look at it. So if y equals 3x in equation number 2, every time I see a y, I'm going to put in 3x. So I have 4x plus 3 times y, which is 3x, equals 26. So 4x plus 9x equals 26. 9 and 4 is 13. 13x equals 26, so x equals 2. Now that x equals 2, to plug it in for y, I'm just going to plug it into this equation right here. So y equals 3 times 2, so y equals 6. The solution to this system of equations is 2, 6. And we're done. That's the substitution method. Now we can do the same thing with word problems. The only difference is you must define your variables. You have to figure out what your equations are to set them up, and then you can solve them. So let's take a look at this. At Ben's Pizza, a soda and 2 slices of pizza cost $10.25. A soda and 4 slices of pizza cost $18.75. Find the cost of each item. So obviously we're trying to find the cost of the soda and the cost of a slice of pizza. Okay, so I'm going to let x equal the soda, and y is going to equal the pizza cost. And then I'm going to take my two equations and I'm simply going to determine an equation based on those. Okay, so for a soda, which is an x, okay, so my first equation is going to be x, and 2 slices of pizza, 2y, equals my total cost of 10.5. My second equation should be a soda and 4 slices of pizza cost $18.75. So equation 2 has a soda, which is x, and 4 slices of pizza, so 4 times a slice of each pizza, and that's going to equal $18.75. So now we have 2 equations and 2 unknowns. It doesn't matter which equation I solve for what, so I'm just going to take this first equation and I'm going to solve it for x. I could take the second equation and solve it for x and say both don't have a constant term in front of the x. So x is going to equal, here in this particular case, x is going to equal 10.25 minus 2y, or negative 2y plus 10.25. It doesn't matter how you write it. I have a tendency most of the time to write it in slope-intercept form, which would be the y before the 10.25, but it doesn't matter. Now I'm going to take that first equation, that x equals 10.25 minus 2y, and plug that in equation 2. Every time I see an x, I'm going to put in 10.25 minus 2y plus 4y equals 18.75. All I did was substitute it in. So I have a negative 2y and a positive 4y, which makes 2y, plus 10.25 equals 18.75. Now I will subtract 10.25, and I will get 2y equals 8.5, or $8.50. Divide that by 2, y equals $4.25. So we now know that a slice of pizza costs $4.25. Now to figure out how much a soda costs, I'll just plug it into the equation I have right here to figure out what my soda cost is. So x will equal 10.25 minus 2 times 4.5. Okay, 10.25 minus 9. So x will equal $1.25. Since this is a word problem, you should answer it in a complete sentence. So I'm going to answer this in a complete sentence. I would just write a soda costs $1.25 and a slice of pizza costs $4.25. And there you have your solution. Simply done if you can set up your variables and set up your equations. Now, not all equations are nicely written so that you have a variable in terms of no constant term in front of it. Therefore, sometimes elimination is a little bit easier to solve an equation. If I was going to solve by elimination, the first thing I want to do is I want to look at my two equations and I want to eliminate something. In other words, if I add equation 1 to equation 2, something should go bye-bye. If it doesn't, then I may have to multiply one of my two equations, or both, by something in order to eliminate a variable. If I look at this first problem right here, I have two equations. This is the first one, this is the second. And if I look at those, if I was to add equation 1 to equation 2, my 8y's will cancel each other out. They'll get eliminated because one's positive and one's negative. So I'm simply going to do that. I'm going to add these two equations together. Negative 2x plus 5x is 3x. These two, 8y and negative 8y cancel out, and negative 8 plus 20 is 12. So I now have 3x equals 12. So I divide by 3, and x will equal 4. Now, to solve for y, I can simply plug it into either equation. It doesn't matter which one I do. I'm going to plug it into equation 1 just because I don't like to deal with any variables as often as I can. So I have negative 2 times 4 plus 8y equals negative 8. So I have negative 8 plus 8y equals negative 8. Okay. So I'm simply going to add 8 to both sides. And I get 8y equals 0. If I divide by 8, obviously y equals 0. So my solution to this system is 4, 0. And again, I could check it to make sure it's right. If I plugged in 4 to the first equation, I'd get negative 8 plus 0 equals negative 8. That's true. If I plug in 4 and 0 into the second equation, 4 times 5 is 20, minus 0 equals 20. Yep, that works too. It checks. Works just fine. Now, in equation number 2, I can't simply just add the two equations together. If I did, I'd get 5m plus 9n equals negative 7, which doesn't do them a bit of good because nothing is eliminated. So here, I need to determine whether I want to get rid of m or I want to get rid of n. And it doesn't matter which variable I choose to get rid of. I'm going to get rid of m. And it doesn't matter. And if I'm going to get rid of m, I need to multiply, I need a common denominator between 2 and 3. Okay? And the common denominator between 2 and 3 is 6. So I need to multiply these two equations in such a way so that I get one to be positive 6 and one to be negative 6. So I'm just going to multiply this equation by negative 3 and the bottom equation by positive 2. I could do it reverse, positive 3 and negative 2. It doesn't really matter. One of them has to be negative, otherwise I'll end up with 6m and 6m, which would be 12m, and they wouldn't eliminate each other. Now, the important thing to remember here is if you're going to multiply an equation by a constant term, multiply every part of the equation by that constant term. That's why I write it up here, so that I don't forget. I have to multiply everything by negative 3. So equation 1 now is negative 6m minus 12n equals positive 12. All I did was multiply everything by a negative 3. The second equation, I'm going to multiply everything by 2, so I'm going to get positive 6m. 2 times 5 is positive 10n, and 2 times negative 3 is negative 6. I now have two new equations, but when I add them together, my m's get eliminated, hence their name elimination. Negative 12n plus 10n is negative 2n, and that's going to equal 6. 12 minus 6 is 6. Divide by negative 2, and n will equal negative 3. So now I have what n equals. I can go back to solve for m, and it can go into any form of the equation. I tend to put it back into one of the original forms, just in case I made a mistake somewhere in the other form, and it's normally smaller numbers anyway. So let's put it back into the first one. So I have 2m plus 4 times negative 3 equals negative 4. So 2m minus 12 equals negative 4. And 12, 2m, negative 4 plus 12 is 8. So 2m equals 8, so m equals 4. So the solution to this system is 4 comma negative 3. Make sure you always put them in order. If they're not in XY form, you put them in alphabetical order, M and N. It's as simple as that. So don't get hung up on that. Wait, it's not an X and a Y. Okay, it's an M and an N. So just put it in M and N form. Because put in an alphabetical order, N first and then N. Next thing we're going to look at is solving a system algebraically does not always provide a unique solution. Okay? Sometimes you'll get infinitely many solutions, sometimes you'll get no solution. When graphing, we know infinitely many solutions, one line lands on top of the other. If you get no solution, you know they're parallel lines. When you get a system of equations to determine whether it's no solution or infinitely many solutions, we have to look at what the solution is telling us. Let's take a look at this first problem here. Letter A, negative 3x plus 5y equals 6, and 6x minus 10y equals 0. I'm going to multiply this first equation by 2. Because if I do that, I'm going to get rid of my x's. Okay, so I'm going to end up with negative 6x plus 10y equals 12. My second equation is just going to stay, so it's 6x minus 10y equals 0. Simply enough, look what happened. Both x and y eliminated, so I get 0 equals 12. 0 never equals 12. That's a false statement. Since it's a false statement, since 0 never equals 12, it's inconsistent. And if it's inconsistent, that means it has no solution. We got a false statement. If you ever get a false statement, okay, right here we got that false statement of 0 equals 12. That's a false statement. 0 does not equal 12. 0 does not equal 12 would be a true statement, but 0 equals 12 is a false statement. If you got 7 equals 7, that's a true statement. If you got 0 equals 0, that's a true statement. But we got a false statement, which makes it an inconsistent system, which makes it no solution. Let's take a look at the second example here. Similar equation, slightly different. I'm going to, again, multiply the top equation by 2. I'll get negative 6x plus 10y equals 12. Second equation, I get 6x minus 10y equals negative 12. If you notice here, everything cancels out. I think it's 0 equals 0, which is always true. This will always be a true statement. Just like if we got 7 equals 7, that's always a true statement as well, which means this is infinitely many solutions. And obviously, if you got something like x equals 6, then you'd go and plug it back in to find your y value. So if you get a true statement, like 7 equals 7, 4 equals 4, negative 2 equals negative 2, that means it's infinitely many solutions. If you get a false statement, 7 equals 12, 0 equals negative 4, that's a false statement. That would be inconsistent. That would be no solution. And this is how you solve systems algebraically.